Despite the fact that we just discussed the distance formula and that the definition of the midpoint of a line segment connecting 2 points, 2 endpoints for that line segment, the definition is that that midpoint M would be the same distance away from either endpoint. Well, we're not using the distance formula. The claim is that we could go halfway in between in the horizontal direction, which would be the same as averaging the endpoints x coordinates, and then vertically also go halfway in between, average the y coordinates of the endpoints, and take those results, make them the x and y coordinates of the midpoint respectively. That's supposed to be the point that is the same distance away from either endpoint. So if I start out with 2 endpoints for that green line segment, P1 and P2, I've got the P1 towards the bottom left in this particular case, and P2, right now it's towards the upper right, sitting on the x-axis. Regardless, if I superimpose a right triangle over that, as I did in the discussion of where the distance formula comes from the Pythagorean theorem, I'm not using the distance formula, but instead I'm going halfway between the point P1 and D. D is the point where we get the right angle. Halfway in between is this point E. That would be taking the average of the x coordinates. And similarly, F, halfway in between D and P2. That's the average of the y coordinates. If through each of those points I were to put a line that is perpendicular to the segment it's on and see for each of those where they meet up, they're going to meet up at the midpoint M. So they're showing up in light blue, and where they intersect, I'm saying that that is the midpoint. And right now that is not proven, but I mean, just look, eyeball it here from P1 to M and from P2 to M. It looks like it's the same distance.